So hope you enjoyed the video, and I think that gives a flyer and idea about the institution that you done, the Institute of Technology, Kottayam. And now we move to our first session, and the topic of the session is AI and ML for next-gen computing. And the expert faculty is Dr. Gopakumar ji. He is an associate professor in computer science and engineering, National Institute of Technology, Calicut. He is a famous academician, especially in the area of bioinformatics, and he has got more than 20 years of experience in both academia and research. He has published papers in reputed journals and has attended world famous international conferences. With your permission, let me welcome Dr. Gopakumar ji for the first session. Thank you, sir.
Thank you, Shibugumar. Am I audible?
Yes.
Okay. Okay. So first of all, I would like to thank Dr. Shibugumar for inviting me, maybe for this session. So I would like to thank the organizers, Undikrishnan sir also, okay, and RIT also for giving an opportunity to share my thoughts maybe in this particular topic. Okay, so I will share my screen. Okay, so we will see. Okay, so is it visible?
Yes, sir, it is visible. Yes.
Okay. Maybe I will. This is also visible, right?
Yes.
Okay, fine. Okay. I will go to. Okay, fine. So I think everyone is actually maybe using AI, and so it's very difficult actually maybe to talk with maybe AI nowadays, because the AI domain itself is actually changing maybe day by day. Okay, a lot of new inventions, maybe new technologies are actually added. So then I thought of maybe how maybe what new thing. Okay, maybe with respect to me sometimes. How can I actually present it? Okay, so I thought of maybe. Hello, I think.
Yeah, hello. Yeah, there was some.
Is it visible right now?
It is visible, yes.
Okay. So I thought of maybe this is a first time I am actually seeing a new feature. I think some of you at least might have actually noticed that you can see maybe a textual description of what was actually told by Dr. Shibugumar. Okay, maybe if you maybe say place your cursor on the top right icon. Okay, maybe. So it's actually Gemini is actually taking the notes. So I have just experienced maybe this is actually an AI maybe say technique. Okay, that we see. So we have actually summary of maybe the session or the speech by Dr. Shibugumar is actually given at the top right portion. So this is one AI. Okay, so similarly we have hundreds of maybe applications nowadays, and these are actually available at our fingertips through our smartphones or maybe on mobile, other maybe computing devices. So the way it actually maybe grows, it is maybe very fast. Okay, so this is one application. Okay, maybe I thought of sharing with you. Okay, so now we will go to maybe today's session. So I will be discussing generally on maybe as this is a first session for an FDP, I thought of maybe sharing some of the fundamentals together with maybe what is going to be the latest technical advancements in this particular field. And maybe I will not go into the details of maybe the machine learning algorithms, because as Dr. Shibugua pointed out, we have actually separate sessions. So anyway, all these are actually starts with maybe AI. Okay, I think most of you are actually from computer science background, and I assume that there are many faculty who are actually maybe new to this particular field, at least maybe on the technical side. So all these are actually starts with maybe AI. So AI is actually artificial intelligence, which actually started maybe very long back. Okay, so where maybe say for example only computer science people, or maybe some cognitive science people, okay, or maybe psychological people, or maybe neuroscientists, they might be working on maybe related areas. So here AI is actually, you can say, is a subfield of computer science that enables machines to mimic human behaviors. So it was actually an old definition. Now we can say that there are machines that who can actually mimic, okay, at least some of the human behavior, maybe to a near perfect way. Okay, so that is a way maybe this AI has actually transformed. So ultimately, maybe when we studied maybe this computational intelligence or artificial intelligence, okay, maybe long back, so the dream of a computer scientist was actually to, okay, create a machine which can actually act like a human being. Okay, so when you think about maybe how a machine can act like a human being, so we can see that maybe one aspect is actually say speech. Another one is say for example vision. Okay, another one can be maybe emotions. Another one is a touch sensitivity. So there are a lot of features which are actually unique to maybe human living beings. Okay, maybe we are actually discussing on, or maybe referring to maybe human beings. Okay, so the same is actually applicable to other living beings also. So then maybe these are the some of the unique features. So now you can see that a machine nowadays, you can have AI systems which has got computer vision capabilities, okay, that can actually recognize its environment through, okay, videos, okay, or maybe images. Then we have actually the machines that can actually talk with you, okay, or you can actually translate actually maybe from language to another language. It can recognize a language that you, okay, make a speech, etc. So in that way, there are a lot of but advancements actually happened. So in that way, maybe some of the features like say touch, okay, maybe that is maybe a domain where which has not actually gone into that maybe successful maybe for the time being, but still there are actually say developments like artificial skin, or you can say that something like is it possible for us to maybe test the smell of a perfume, okay, through Amazon or maybe Flipkart. So something like an electronic nose. Okay, so there are already research into that direction. I think maybe in the coming years, maybe very fastly. Okay, so such capabilities will also be added to maybe our maybe this AI systems. So that is that's a really interesting and maybe okay. Fascinating. So when it comes to AI, there are a lot of terminologies like machine learning, deep learning, reinforcement learning, supervised learning, unsupervised learning. Okay, and nowadays we have a generative AI, and there are a lot of most of these are actually subdomains of maybe artificial intelligence. So it's a very broad umbrella. AI is actually okay. So when it comes to maybe the different terminologies, machine learning is actually the most popular, and maybe the first one that actually established in this particular say series of maybe say subdomains. Okay. And when it comes to machine learning, we'll go into some more deeper later. Okay, but we can say that generally these are actually systems used to predict it. Okay, maybe a particular task. Okay, so you are say for example, Shibhukumar sir actually mentioned about there is a requirement of say 80% attendance, okay, maybe for completion, and some of the FDPs will be coming with some assignments or maybe quizzes and maybe a test where you have to pass the, or you have to obtain maybe a particular percentage of marks actually to, okay, to get the certificates. So now here we have a task. So for example, we have around 170, 180 plus participants here, and maybe most of you are actually registered. Okay, so then is it possible to predict, maybe looking at the profile of each say participants, whether a particular participant will maybe make 80 percentage mark? Okay, suppose you collect some data, and or how many of you will fail? Okay, is there any possibility of fail for a particular person? So this can be a task, so where you are predicting whether a particular person will get 80 percentage mark or a particular person will fail. Okay, so that can be a problem that we will take maybe during the discussion. Okay, so generally the machine learning is about generally it's a predictive models. So that is constructing predictive models from a large number of examples, because you know that our learning generally happens through examples. Okay, because we also learned through different ways. Maybe from childhood days we learned from feedback from our parents or maybe relatives or maybe nearby maybe say objects. Okay, and then we might have read a lot of maybe say comics or maybe other books. Okay, then we started reading textbooks. So in that way, different ways, and we have actually learned a lot of things. So that's a way maybe machine learning happens also. Okay, and when it comes to deep learning, so again, it is actually a subdomain coming a specific focused area in machine learning. Okay, where maybe it actually overcomes some of the limitations of machine learning. Okay, so we will come to that point later. Okay, so again, you can see that it can actually learn complex patterns from data, which was not possible with the machine learning models. So that is maybe where deep learning stands actually. And okay, we'll come to this particular point later. Okay, but maybe there are different types of networks you might have came across with feed-forward neural networks. Sometimes, as Shubhumar sir pointed out, convolutional neural networks, recurrent neural networks. At least some of you may be knowing about transformers. Okay, maybe other persons will be knowing about transformer, maybe a KCB transformer. So you can make a comparison of maybe if you are actually on that field, is maybe the real transformer that we will discuss later, where that has got some similarity, because those who are actually new to this field may not be knowing about what are transformers. But these are actually some of the architectures, maybe deep learning architectures that has actually transformed maybe the way we see AI systems. So that is a important part. Okay, so you don't need to worry about this architecture, etc. We'll come to that point later, or you'll come across with maybe this transformer, RNN, neural network. All these you will study in detail in the coming sessions. Okay, and you might have seen there are a lot of maybe say again terms like supervised machine learning, unsupervised machine learning, semi-supervised reinforcement learning, and we have a self-supervised machine learning, which is actually a latest one. Okay, so again, these are actually of different kind. We'll come to that point later. Anyway, so when it comes to supervised machine learning, so for example, we have a for example, we'll come to maybe this example. For example, say we have a we'll represent maybe some of the participants' data here. Okay, so when you so the task here is so we want to predict whether a particular participant will pass or fail. Okay, so pass or fail. So that is actually our aim. Okay, so then what are the things that we have to consider whether a particular candidate will pass this particular examination or this FDP, or you will get a certificate or not. Okay, so then maybe you can think of what are the features or what are the things that we have to consider. So maybe what we can consider. Okay, any idea, any suggestions? Maybe say for example how much
number of hours spent by participants.
Okay, that's good. Okay, so for example, number of hours, okay, maybe spend can be of different ways. Okay, that's a valid point. So for example, you can actually really listen to the content. Okay, or you can just maybe log in and maybe you can listen to some other. Okay, maybe say, or you can engage in some other activities. So anyway, a number of hours spent, maybe quality hours spent can be okay. One of the say feature or particular thing that we can consider. That is one possible okay thing. Okay, any other possibility? I mean,
Assignments.
pardon?
Assignments.
Okay. So whether a particular person is submitting assignment or not. Okay. So assignment submitting or not.
Feedback forms.
Okay. Feedback form. So okay. Any other? I mean, maybe we are actually looking into maybe whatever is happening in this FDP only. Okay. So that is maybe these are let us say these things we are actually considering. So that means we have a 1, 2, 3. Okay, so 3 things that we have considered. We call them as features. Okay, but when you so features are actually used in machine learning terminology, but there are other names like dimensions, random variables, okay, attributes. So these are actually the different terminologies used for the same thing, maybe in different fields. So for example, one in statistics, one in database technologies. Okay, so that way, maybe one in linear algebra. So anyway, I assume that there are 3 features we consider. Okay, and then we will list out what is participant 1, what is participant 2, what is participant 3. Let us say participant 170. There are 170 participants. So we will note down, maybe Shibumar sir will note down, okay, so for example, hours spent, assignments and feedback. Okay, but here one issue is actually we don't know, maybe the pass or fail we will get maybe only after the completion of this maybe FDP. So we don't have any maybe historical data, okay, at the moment, maybe for these participants. So that means we don't have whether P1, participant 1 will fail or not. Okay, that information is not at this moment. So now, can you suggest any way, maybe how we can tackle this problem? Suppose we want to, maybe say, for example, group, okay, maybe these participants 1 through 170 into some meaningful group. So that we say that, okay, participants in this particular group, okay, will be passing this FDP and the other will be failing. Okay, so that is one way of maybe approaching this problem. Okay, so for example, assume that we are having all the 170. Okay, so suppose we have a 3-dimensional system here, right? Because on x-axis you can have maybe the hours, okay, and on y-axis you can have assignment submitted, and on z-axis you can have maybe the feedback submitted, etc. So so you can have a P1, you can plot, okay, somewhere here, suppose you plot a P1, okay, and assume that you plot maybe, say, for example, P2 here, and similarly, you can plot a 170 somewhere, okay, maybe it's a 3-dimensional, okay, system. Okay, maybe if all these are actually positive values, then accordingly, the points will come. So that means where the features are actually taken as maybe in this context a 3-dimensional vector, okay, where the first component represents hours, the second, okay, so like that. And now what we require is we have to group into, say, how many groups we may have to group here? Maybe if you have any idea. Am I audible?
Yes, yes, yes.
Yes,
You're
yes.
audible.
Correct.
Okay, so anyway, we have to group this into 2 groups because we know that we are our aim is to group into 2, okay, because pass or fail. So this 170 has to be grouped into 2 so that we know that okay, in one group we have a subset of maybe P1 through P170, and the rest of them will be in second group. Okay. So in that way, we can actually say, for example, find maybe That's the only way at this moment. Okay. So then assume that a P2, okay, is in this one, P50 is here, P170 is here, but P1 here, so for example, P48 here, like that it goes. So then what we can do, so this is actually a type of learning where you don't have any idea about the pass or fail, but you are actually, finding out it through groupings. So, okay. So once you have found out maybe this grouping, what you can do is, so for example, P2, we will say that it is pass, okay? And P70 is also on the same, so we can write a pass, okay? And similarly, okay, P1 is actually failed. So we will find out something like this one, okay? But that may not be the real one, okay? But suppose we have identified such a, labels here, okay? Then, assume that at the end of maybe this FDP, the results are actually out, okay? And then we look at what about the P1, the first candidate, whether pass or fail. So assume that he failed, okay? I'm not, I don't want anyone to fail, okay? Anyway, okay, any comments?
So there was the hand raise.
Okay. I think, any questions? Okay.
Sir, you may continue and we will give some time later for.
Okay. Fine.
Okay.
Okay, fine. So that means suppose that candidate failed. Okay, the next one actually again failed. Okay, and maybe the last one, maybe you can note it down and assume that is pass. So here assume that we have actually the first one is actually we have grouped, and now if you have identified maybe what is the real, okay, maybe performance, so that you get, okay. So now we can actually make a comparison, okay, how many failure predict you have got fail, and how many pass you have actually found out was a real pass. So in that way you can evaluate what was the error, okay, maybe in identifying, okay, in that particular, say, given problem. But here, what we have done initially is actually got an unsupervised learning where you don't have any label about the pass or fail information for that candidate. So we grouped them looking at the 3 feature values or their combinations. Okay, some patterns. Okay, and what we have predicted is actually the last one where you can actually evaluate really whether that your grouping was actually meaningful. Okay, so now what you can do is assume that you have got now the correct predictions. Okay, so for example, that means these are going to be the real real values. Okay, because so now assume that you just forget about this column. Okay, so now assume that you have a data set of all these participants with pass or fail for this particular FDP. So then how we can use this one for the next, suppose the another, say for example, CET or some other college is actually planning to organize it, and they are interested to look at maybe a particular candidate who has actually failed, okay, whether they should be allowed to attend that FDP or not. So in that case, you have an historical data, at least one sampled, okay, so that they will ask RIT, okay, Shibumar sir and Shibumar share this particular data set, okay. So in that case, so that you have an information, okay, and they can actually now develop a maybe a machine learning model. The first one was also a machine learning model, which is unsupervised learning, where the label was not there, but now you have a another maybe type of machine learning problem where you have a label is there, okay. So the CET organizers can look into this particular data and they can actually develop a system so that whether it is possible that feature 1, okay, feature 2, feature 3 as given, and whether that using this particular data, is it possible to predict for their, okay, FDP organized, okay. So then in that way, the system should predict whether pass or fail, and you are given hours spent, assignment submitted or not, maybe feedback. Okay. These are it's a very basic example, okay. So that is called a supervised learning. Okay, so that is supervised learning. Maybe in this diagram it is clear. You have a label data and you have different labels, and you have an ML model, machine learning model, and it will predict maybe, so for example, some test data. So here we have two types of data, training data and test data, where training data is actually used for, training the ML model. And the test data is, so for example, the CET organizers would like to see whether one of their participant who did not actually attend the RITs, say for example FDP, whether they will pass or fail, or any other such cases. So that is actually got a supervised machine learning problem. So you will be saying many of the techniques like linear regression, some of the conventional machine learning problem, logistic regression, support vector machines, naive-based classifier, decision trees, artificial neural networks, random forest. There are a lot of such standard techniques. They are actually some of the fundamental machine learning models. And then at the same time, you can have deep learning models like a neural network, RNN, CNN. Maybe most of the latest maybe deep learning models. So this is generally about the supervised machine learning. And when it comes to unsupervised, you can see that our example, you have an unlabeled data, and you have to find out, you develop a system so that it will group into similar, pattern objects. So that is we call it as a clustering, because you are clustering the given, objects. And there are different kinds of clustering algorithms, so like a k-means clustering, hierarchical clustering, density-based clustering, grid-based clustering. So they also all are having maybe the advantages and limitations. And then there are other maybe deep learning models which does not require actually maybe labeled data, because see the first kind is actually very limited, because here the success of your machine learning model is actually depend upon how you decide on your features. So that require you should be an expert in maybe in designing the the features. So for example, in our case, we have just listed 3 features, but are the real features that can be used, or something, some other features are actually there which can actually give a better prediction, or better modeling of maybe the FDP pass or fail problem. So that is a challenge, and this can be a challenge when you talk about, for example, you have an object identification, object detection, like so for example, you have a classical example is dog cat distinction, because you know that the images are actually represented as metrics, maybe in computer, and so when the resolution increases or the image contains maybe many objects, then it is challenging actually. So there again we look for some features, but it is very difficult even for an expert to identify which are the best features that will, say for example, distinguish one dog from cat, or maybe from another, say for example, parrot, or maybe a face of, say for example, Mohanlal or some others. So all these are actually really challenging. So you cannot actually simply identify 5 features, and maybe you can say that you can predict, this is dog and this is cat, because you just think, how we recognize maybe person to person. So our brain actually processes, for example, human faces. And you please note that all of us, or majority, are having, say for example, 2 eyes, 1 nose, and 1 mouth. All these are actually common elements. But there is a subtle changes that is actually happening, on maybe how these are actually arranged, or some combinations of this has got some uniqueness which actually recognizes or distinguishes one person from another person. So if you think this is really amazing, and how fast our brain is actually recognizing these patterns. So that is a very interesting problem. So earlier it was actually very difficult for a machine actually to recognize human faces, but now it is very fast. You can see that you have image captioning and other things, or maybe object recognition. A lot of deep learning models which can easily recognize and label maybe different objects. So that's a way we have all these are actually advanced, but that's a fundamental problems are actually these ones. Okay, so that is called unsupervised learning and supervised learning. Okay, maybe this is a slide, I will skip it. And now there is another interesting maybe a problem called semi-supervised learning. Okay, so which is nothing but you have some input data is there, okay, but not all the maybe say samples are actually labeled, but some of them has got labels and some of them does not have a label. So that is a real life or real-time scenario, because if you look into maybe say for example internet, okay, we can see maybe even millions of say millions or billions of images, okay, and we will not be able to recognize maybe each of the images, because maybe say people all over the world might have taken photographs of say for example different objects which are majority unknown to us, okay, and they have actually put over the internet. So is it, we cannot actually label, okay, maybe this object belongs to this one humanly. Okay, so people thought of why we can actually, why don't we combine, okay, maybe some maybe input data wherever you have labels already there, okay, and you take those objects without labels, and you build a machine learning model so that it can actually predict the label for an object, okay, for which the label was not there, okay, a label of a particular object which was not there in the original data set. Okay, so that actually increases, okay, or it has got a tremendous power, and which is actually the the building blocks of, maybe you might have heard of some technique called foundation models, okay, or maybe this generative AI systems or foundation models, which is actually working based on this particular principle. Okay, so that is maybe you may have maybe sessions on this particular, okay, maybe at a later days. Okay, so when it comes to machine learning, generally we have two types of machine learning, because machine learning, it's a very fundamental, okay, technique. Maybe we have seen that these are the first maybe domain established. You have a discriminative and a generative, okay, techniques. Okay, so here discriminative means you can see that on the right side you have a red and blue, okay, dots or circles, which are actually separated by one boundary. Okay, we call it as a decision boundary. Okay, so here what we are looking is actually, is it possible for us to identify a decision region? Okay, maybe a curve, any type of curve. It can be a straight line, it can be a dot, or it can be a, some of you might have heard of a splines. Okay, or any, maybe any polynomial, okay, or any continuous curves, or this non-contiguous, or any such possible curves. Is it possible for us to propose, okay, or approximate a particular function which can be plotted, okay, and that will separate the given data points into maybe separate categories. So that is called discriminative. But and another way is actually looking at solving the same problem is it possible for you to generate a probability distribution, okay, of maybe these separate classes of points, and using that probability distribution, is it possible to maybe distinguish them? So that is actually another way of maybe looking at the same problem, but it has got some advantages, because if you can generate a probability distribution from the given data, what you can do is you can sample, okay, new, okay, points of similar kinds, okay, from that probability distribution. Okay, and that can be used for generating new data. So that is one advantage of using probabilistic models. But there are some additional information sometimes you require for probabilistic models to perform as expected, but that can be quite challenging, or sometimes that information may not be maybe aptly available for us. So these are two maybe strategies that has been followed. Okay, so this is again, okay, another way of looking at the things. Okay. So that is the case. Maybe this I will skip it. Okay. So you can see that when it comes to, okay, generative AI, okay, I think generative machine learning, okay, or generative AI, okay, I will come to that generative AI later, but it is nothing but you have, as I already mentioned, it is a function approximation. What we are doing in machine learning or in deep learning is a function approximation where you are predicting a output Y for a given X. Maybe in our context, that is, for example, in our previous case, we have a X is going to be the feature vector. Okay, the 3 components. Okay, and Y is actually going to be maybe, say, for example, pass or fail. Okay, maybe in our context. Okay, and what you have to find out is an F. Okay, which actually maps maybe this X values into Y values. Okay, so that is so that I mean generally about this systems. Okay, and you can see that so for example, Y can be a number. That means you are predicting or you are finding out a numerical value. Okay, in such cases, sometimes we call it as a regression problem. Okay, and you can have discrete values. So, for example, in our case, it was a pass or fail. Okay, so is it possible for you to propose maybe how we can convert this pass or fail into when it comes to discrete, we call it as a classification problem. Okay, so what we have actually seen is a classification problem. Okay, classification, because it actually predicts a discrete states. Okay, so another problem is a regression problem. Okay, regression problem, which actually need to predict a numerical value, maybe a real value. Okay, so anyway, how we can actually predict or change our given problem into a regression problem? Any idea? Any suggestion? Okay, it's nothing but the pass or fail. Assume that you assign a mark, okay, for example, out of 100. Okay, for number of hours, you give a weightage. For assignment submission, you give another weightage, and assume that you have a marks obtained for each of these multiplied by their weights. Okay, and then you maybe scale that into maybe 100. Okay, so that you have a score. Okay, out of 100. I think that is possible. Okay, so in that case, you are actually going to predict what is the marks obtained for the FDP. Okay, so in that case, you can say that that's a regression problem. Okay, where you are predicting the marks. Okay, so that means you can have a number, discrete values, class. Okay, probability value. All these can be predicted. Okay, so that means they are actually the case of maybe. Normal machine learning. But when it comes to another area, maybe again a focused area in the deep learning called a generative, okay, AI. Suppose the Y is actually a natural language. Okay, or that means, so for example, a sentence in English or sentence in Malayalam or in Tamil or in Hindi, etc. Or assume that you have given maybe one text as input, okay, maybe a description of a scenario, and assume that an image is generated. Okay, so you are converting a text data to image. So again, that Y is an image. Okay, then you have it's a generative AI. Similarly, assume that we have seen audio as input. Shibumasa's speech was actually input, and a summary of in text format was actually the output. So that is a generative AI system, because you are generating maybe either text, okay, or audio or video or image, or even, I think you know about Copilot. Okay, or maybe we have a code-based generators are actually there. Okay, where even you'll get every code nowadays. Okay, simply just ask maybe any generative model. Okay, ready for that, it can actually generate maybe any code, any source code for a particular problem solving in any of the languages like C, C++, Python, Java. Okay, so that way it generates maybe code. Okay, so all these are actually different, maybe, but the scenario is the equation or the fundamental remains the same. Y is equal to f of x. Okay, so that's the way it goes. And there is another system which is actually slightly different from maybe whatever we have discussed. Here it is the way maybe human brain actually learns. Okay, so generally we might have learned through some feedback, okay, that we get from environment, or we will be taking some action, okay, and the environment will give some feedback, okay, based on our action, okay, and based on that we will be learning, okay, ourselves. So that is an area which is called reinforcement learning. Okay, and all of us actually learned maybe, for example, I don't know whether it is a 50 percentage from textbook and from others, and maybe 50 percentage from by our own, okay, maybe from environment. Okay, so that way only we learn. Okay, so that is called a reinforcement learning. You are reinforcing some scenarios, okay, and generally what is actually happening here is if you are actually taking a correct action, okay, or a favorable, okay, or what is expected action, you will be getting a reward. And assume that if the action that you are actually taking for a particular scenario is actually wrong or not expected, then you will be getting maybe negative reward or sometimes penalty, etc. Okay, so for example, autonomous cars, okay, driving, maybe many of the autonomous systems are actually working on reinforcement learning. Okay, so here comes a concept called agent. Okay, so I think some of you might have gone through some of the terminologies like agentic AI. Okay, so where an agent will be learning from its own. Okay, you don't need to give any maybe say scenarios and teach it. Okay, so there are an area called agentic AI, which actually it's again a very hot topic in this particular context. Okay, and many games. Okay, I think you might have heard of at least DeepMind. Okay, it's a Deep Blue. Okay, I think the first chess program that beat maybe Gary Kasparov, then Grandmaster. Okay, and you might have heard of AlphaGo. Okay, AlphaGo. Go is actually a game which is considered to be even more complex than chess. Okay, and AlphaGo is actually a program from Google, which actually beat the world Go champion. Okay, so nowadays I think you can say in game playing we cannot actually beat any of these AI systems because they have a lot of prediction capabilities. They can actually analyze, okay, maybe hundreds or even thousands of move ahead, which not possible for human brain to process. So we can maybe predict maybe next 5 steps or 10 steps, but that is not the case with these type of AI systems. Okay, so robotic systems, everything actually you require reinforcement learning. So this is another way of learning. I think you will be having separate session on reinforcement learning. There are many interesting algorithms, and because you need some probabilistic systems like hidden Markov models. Okay, and there are some policy systems that you have to design for developing reinforcement learning systems. Okay, so that is actually generally about systems. So we'll go to maybe another slide where maybe at least so maybe some more classification. I think this is assume that there are 2 cases. Okay, one is you have a minus circles and plus circles. So just those who are actually not that much familiar into machine learning. So what we require is actually you can have a decision rule. Okay, last I mentioned about the decision boundaries. So, and you can say that on one part of, on one side of that decision boundary is, say for example, one kind of objects, and on the other side you are having another kind. So then you can say that that particular decision boundary separates the points. But in real situations, that separation may not be because as you expected, exact separation, because in reality the data is, we will call it as a non-linear data. So because there can be linear and non-linear cases. So that is a important case. Say for example, suppose this is one example where you can say that the data is well separated. Maybe just for showing the the complexity or the complex nature of data. Here you can see that you can easily find out a say boundary like this one. Maybe you are saying that on this side you are having we say region 1, and this we have a region 2. It is very easy to separate it. But assume that you are having situations like this one. At least some of you might have seen. And so for example, we have one here and one here, and one here. Problem, the data points are actually not linearly separable, because you cannot actually draw a line on this plane, or sometimes maybe in higher dimension also, assume that you cannot draw a linear model on that maybe say in 10th dimension or in 7th dimension, whatever, how many features you are considering. But here we know that if you want any say for example a decision boundary, where how we can actually draw, it's a complicated one. So for example, you say that you have there are points. So there are points. Assume that they are having there are points, something like this one. So you are expected to bring such a system or a decision boundary, and where we say that on this portion region you are saying R1, and on this side of this we see all this R2. So that means we can, if you know the equation of this curve, then you can easily separate even this non-linear case. But the interesting point is usually that the non-linearity of the real-time data that we consider is actually non-predictable. Can be any complex non-linearity, it can come. So anyone who can actually predict or say what is going to be the equation for this particular decision boundary, I think that is really challenging. Because it is not a second degree polynomial, third degree polynomial. So these are actually high dimensional maybe say curves. We generally call it as splines. So that's a really tough to predict. But these machine learning techniques actually each of them, that means for example artificial neural network, it will try to find out maybe this non-linear in one particular way through some non-linear functions applied onto this maybe some maybe arrangements, and another technique called support vector machines. So it will actually try to find out maybe this particular say decision boundary through mapping this data into some higher dimension where the data will be linearly separable. So for example, here we know that this is a two-dimensional data, because we have only 2 points, and we assume that it's a two-dimensional. Sometimes suppose you map this point into, suppose here you have x1 and x2. Assume that you identify x1, x2, x3, x4. So that the fourth dimension, where this points will be separated by a linear, maybe line on that particular dimension. So in that case, you can see that on fourth dimension, it is actually separable. But when you map that into two-dimensional, that line will be look like it is green. So SVM actually solved this problem in a different way. maybe say for example, decision tree. Okay, it's another supervised learning problem that actually solves this in another way. Okay, so I think, say for example, in decision tree, it will actually divide this, okay, planes into maybe on different, okay, kind, okay, and then it will find out some regions. Okay, anyway, so we are not going to the details of each and every one. The point is that each of the machine learning has got solved this problem maybe in different way, and they have got advantages and disadvantages. Okay, so that is something like a decision rule is very important. Okay, this is a very simple example. Okay, so for example, if income which is on x-axis and the savings on y-axis, you say that if income greater than a particular value and savings greater than theta 2, you say that it is a low risk group, else you have a high risk group. So it's a simple classification rule. Okay, so that is the case. Okay, maybe this I am skipping. I mentioned about maybe predicting a numerical value, maybe the marks of maybe FDP, okay, participants, where generally the model is actually something like a WX plus W0, something like a MX plus C type of equation. But in machine learning, we use maybe the terms generally W, okay, which are weights, okay, and maybe W0, sometimes we call it as bias. So what we require maybe here is you're given a training data. So that means in our context, the training data is actually the tabular data that we have seen on the last slide. And you have to predict, maybe you have to find out equation for this Y from the given training data. Okay, so that is a problem. Okay, and we call this W as parameters. Okay, and we have to find out this W0 and W vector. So actually it can be an n-dimensional vector generally. Okay, so you can say that you have a W1, W2, W3, etc. to Wn. Similarly, you have n features, x1, x2, x3, etc. Maybe in our example, we had 3 features. So you'll have your model will be having W0 plus W1 x1 plus W2 x2 plus W3 x3. Okay. So then you have to find out the values of W0 through W1, 2, 3, okay, from the given training data. So that phase is actually called a training phase. And unsupervised learning, I think we have seen reinforcement also. Okay. So just I'm skipping. Okay, this one. So we come to maybe. So you can see that it's a very challenging. Okay, input formats are actually available. Okay, because when you look into data, okay, in the nature, we can see different kinds of data, complex data and simple data. Okay, for example, in our case, the number of hours okay attended, feedback returned, assignment marks, these are actually numerical and very simple. Okay, but if you look into nature, there can be some complex relationship existing among maybe, so for example, a set of objects that you consider. It can be a graph in shape. Okay, it can be tables, it can be videos, audios. Okay, there are a lot of different kinds of input you can expect to a machine learning system. Okay, so then processing and the method that best suit for a particular type of input is also different. Okay, because the technique that you have designed for some numerical data or some text data will not be applicable for, or the best suited for graphical data. Okay, so but there are some networks like a graph neural networks. Okay, and its variants are actually there, which are actually exclusively generated for, or maybe created for analyzing the graph networks. Okay, so that is way the things are actually already changed. Okay. And another important point is maybe the pre-processing of the data is a very crucial one, because whatever quality you expect is actually depending upon quality of your data. Okay, so that is another important step which we call this a data pre-processing or data cleaning or data cleansing. Okay. Okay, there are some requirement for data visualization also, because some of the patterns you can actually easily plot and see whether any particular patterns exist there, and depending upon that intuition or visualization, you can actually even choose some of the data pre-processing techniques. Okay, like something like a principal component analysis, okay, or maybe some other normalization, or that can give you an intuition. Okay, but again, you just think about you have a 50 points, you can easily plot and see. Okay, whether any such patterns or maybe interesting necessary is there. But when you look into millions or even billions of maybe say data, you cannot actually simply plot on a plotting tool. But there are some other techniques which can actually generate visualizations for even the large scale data. So that is the case. Okay, here also I'm just skipping. Okay, some of these we have already discussed them. Okay. Okay, then another one, a very important thing that should be kept in mind is actually usually we say, for example, for the FDP problem, we are having, say, for example, 170 participants that we have actually collected, okay, the data. Assume that the AICT is actually conducting a lot of adult FDPs, and so for example, CET is actually getting say RIT data, okay, a lot. Okay, so here assume that if you consider all the adult FDPs conducted by AITs, you'll have maybe hundreds of adult FDPs might be conducted by AICT, but CET will not be able to get all such information. So that means you have a population, but assume that you are getting a one sample here. Okay, then you should maybe you should be satisfied with the one sample generally. Okay, because when you consider medical data, or say for example data from a scientific experiment, or say for example you have a Shubhamshu Shukla, for example, when the International Space Station, assume that the data generated by them, okay, it's a very unique data. It's only one sample. You cannot actually repeat that experiment. So from that one sample, how can you maybe generalize the results or the findings that you have actually obtained? Okay, so that is a crucial one. So that means you have a population and you have a sample. Okay, and generally we assume that each training sample that we are having is drawn from an probability distribution, because we expect that all this data is generated by, whether it is a medical data or it is from maybe some scientific experiment, or from, say, for example, people maybe say recommendation systems or purchase patterns. These are might be generated by some probability distributions. And usually you cannot again, so for example, weather forecasting, we cannot actually simply approximate only. We cannot actually simply take which is the exact probability distribution that generated this data. So it's again an approximation. Okay, so we will assume that maybe Gaussian distribution is the best one to describe this process, or maybe binomial or some other distributions. Okay, so we assume that the distributions is actually identical distribution. Okay, and they are independent. So that means if you are sampling first one and second one, the second one is actually not influenced by the first ones. Okay, so that way identical, independent and identically distributed, IID. Okay, we assume that. Okay, and only with this assumption we can actually go ahead with maybe the machine learning analysis that we have seen. Okay, and we expect that the test examples are also drawn in exactly the same way. Okay, because you develop the system for one probability distribution and you test the system using from samples from other one is actually not expected to maybe give the real analysis or the evaluation of your model. So these are actually very important, the sampling assumption. Okay, so that is the case. And maybe there are some concepts called maybe fitting a polynomial, as already mentioned. Okay, assume that you have a maybe a set of points and assume that you are having a sine wave. Okay, so for example, generated some of the points and you have some noise added to those points so that you have some drift from the original curve. And assume that you are given this blue circles. Is it possible for you to predict it? Okay, the function that it has generated. So then you can actually propose different kinds of maybe models. So the red ones are actually the proposed models. Okay, and the green one is actually the real one, which is unknown to us. So, for example, if you take any real, world data set, we don't know exactly. So, for example, you take a cancer data set. Okay, so we don't know which biological process, and that biological process follows which particular pattern or which distribution, which way you can represent that process. Probabilistically, it is a very difficult to model. Okay, so we assume that there is a model which has generated by generated this particular sample, and what we look for is it possible? Say, for example, we say that we are going to approximate with a polynomial with a degree m is equal to 0, m is equal to 1, m is equal to 3, m is equal to 9. Okay, so this is actually called a concept called bias. Okay, so for example, there is a concept called bias variance trade-off. Okay, which is again a very crucial in basic machine learning. Okay, so here, so we are actually approximating a model, okay, for a given real world problem. Okay, so you are actually having some bias towards, okay, maybe that particular model, but the reality may be very different from, okay, what you are actually proposing. So that is the thing. And in some cases, so for example, if you look into the top left one, you can say that the proposed one, polynomial with m is equal to 0 is very distant from the real one. Okay, but when you look into maybe the last one, that is a bottom right one with m is equal to 9, that means a 9th degree polynomial, we can see that it goes through each of the points, okay, but not a good approximation to the green one. But when you take a m is equal to 3, okay, we can see that the red one is very near to or very similar to the original one, which is unknown. Okay, so this is the best one, maybe the m is equal to 3 case. Okay, so the top left one is actually, we call it as underfitting, because it is actually not utilizing majority of the data, or the patterns of the data is not captured by that model. But on the bottom right, you are having it is called an overfitting. Okay, the first one is called underfitting. This one is called overfitting, where it overly fits the training, okay, the given data, so that it may not be able to predict what is going to be the next one. Okay, because it is something like a spoon feeding. Okay, some people will be able to answer all the questions that was given in the maybe class. Okay, but they will not be able to answer maybe a slightly different question. Okay, so that is that's what happening. So here maybe m is equal to 3 may be a better choice. Okay, consider. So these are actually again a crucial thing that will come. Okay, that depends on how complex is your model. So here, if you look into the 4 cases, m is equal to 9 is a complex model. Okay, for the given data, but m is equal to 0 is a very simple model. Okay, so that is another issue that we have to take it. So we can see that these deep learning systems or machine learning system, all these are actually maybe say can be affected. Their performance can be affected with this fitting problem, overfitting and underfitting, and there are techniques incorporated into their architecture. Okay, maybe to minimize these effects. Okay, so that is another one. Okay, again, these are some of the same slides. Okay. And there are some techniques, like maybe error, you can, say how much is a loss. Okay. Maybe we have seen that already a fail candidate that we have identified is really again fail. Okay, at the end of the examination, then you can say that's a correct prediction, correct match. Okay, similarly you can find out a loss. Okay, maybe for the predicted one and for the the original one, if it is available. Okay, classification error. Okay, and ultimately what we are looking is actually to minimize the error. Okay, and when it comes to this regression problem, you can say that that's a numerical value you are comparing. So what is the difference between them and its square, something like that. So that's, we call it as a squared error. Okay, So you can see that the last one, ya minus f of xi the whole square. So because we are trying to minimize the difference between or square of the difference between maybe this case. Okay. So that is a way how we can evaluate systems. And interestingly, there are many standard loss functions, okay, which are actually part of machine learning systems, because these are exclusively for machine learning better suitable. But there are some specialized ones when it comes to deep learning system, like cross entropy, okay, and other things like that. And now here there is a very interesting, another issue called cost benefit analysis. So, for example, assume that you have actually you have a problem. So, for example, here assume that you are predicting whether a particular candidate will pass or fail the FDP. And for each of that, what is going to be the risk associated with that decision? Okay. So I think maybe when you consider that scenario, assume that you have predicted as fail and that particular person failed, what maximum what the effect can be. So for example, that a 5 days salary or 5 days duty leave will not be given for a failed candidate. That can be one maybe risk associated with it. Okay, maybe that is not a part of the machine learning model, but it's part of the decision that you have made. Okay, and for example, those who have actually passed, they will be getting some credit points, so that that will help in the promotion. Okay, that is the reason. But when it comes to, okay, so for example, what is going to be the risk? Assume that you have predicted a candidate who was really passed, but you have predicted as failed. So the maybe the risk associated is actually not that great. Okay, when you compare with a patient, okay, where you have predicted wrongly. Okay, assume that a person was really a patient, but you have predicted that he's a normal person. Okay, that is one scenario. And the other way is also there. Suppose you are having a normal person, but predicted maybe as a patient. So you can just see that for each of this decision, you will have some risk associated with it. So which one is having higher risk? So that is a very crucial one. Okay, so in some scenarios, this risk is actually very important. Okay. Okay, so that is another one. So this is the same thing. Okay. Okay, maybe there are some techniques called regularization, etc., to avoid this overfitting problem. Okay, so we are not going to the details of that one. Then usually there are some parameters associated with this machine learning models called hyperparameters. So which are actually not parameters of the machine learning model, but there are actually some user-defined parameters or parameters that has actually resulted out of maybe trial and error, okay, etc. So such parameters are called hyperparameters. Okay, so then sometimes we may have to find out which is the best hyperparameter for a given maybe our model. So then what we will do is we will divide the whole data available into train set, okay, validation set, and test set. So the train set is used for model building. Validation set, generally we will use it to find out the best values for the validation, hyperparameters, and test set we use it to find out the generalization errors. That means how well this model is generalized into unseen, okay, samples. So these are very standard, okay, split, okay, into three. Okay, so then there is another technical k-fold cross validation. I'm not going to the thing. So this is another one: accuracy, precision, sensitivity, specificity, etc., etc. Okay, there are F1 score. Okay, there are a lot of such measures. These are called classification. For regression also, you can find out a root mean square error. Then different kind of problems, you will have a different evaluation metric. Okay, so this is very crucial. Okay, and there is a technique called receiver operating characters ROC curve, and there is an area under ROC AUC value. So these are actually some evaluation criteria. Okay, so that is actually briefly about maybe this machine learning, and then we'll go to another slide. Okay, I mean, I think there's a latest one. What is actually happening maybe in this area is actually generative AI. Okay, again you can see that how they are related: AI, ML, DL, and Gen AI. Okay, so again these are actually some focused areas in each of this. Okay, I mean cases. Okay. So now what is generative AI? From the name itself, you will get what is it is generating. Okay, so it is generating anything. Okay, you can see this. Okay, so it can generate text, it can generate audio, video. Okay, code. Okay, or maybe anything like that. Okay, so synthetic data. Okay. So nowadays, earlier getting a data set for maybe doing some experimentation is actually really challenging. Now even you can use the generative AI systems to synthetically generate the data. So that is another maybe thing. So I'm not actually going to again the details, but you can see that I mean there is a I think we have seen a architectural transformer, which is actually uh, the fundamental path breaking discovery, or say architecture that has actually transformed, or maybe the reason behind the very famous Gen AI tool called ChatGPT. Okay, I think we have a GPT, ChatGPT, 4, and maybe I think 5 is going to be released. Okay, and it is by OpenAI. Okay, I think recently I think Sam Altman, I think the CEO of OpenAI, has actually predicted that in the near future we will have smartphones, laptops and other computing devices will be obsolete. Okay, and there should be some new device will be coming. Okay, which are going to or which will be the best for processing maybe AI systems or maybe generative AI. Okay, so that means you can expect that our smartphones will also change. So we can just have an imagination. We can see what type of a hardware device will come to us. Whether we will have any device or we'll have a some of you might be saying AR, augmented reality kind of glass or anything. Sometimes that can be one thing, or even is it possible you have a some other say I mean you have the earphone kind of thing, whether that will be able to process. We don't know what type of device is going to come. Anyway, that's the way the things are changing. And you have image generation, you might have heard of. Okay, you have there's a famous tool called stable diffusion. So you can create images that are visually similar to the real world images. Okay, so that's another one. There is another famous tool called Mid Journey. Okay, DALI. Okay, all these are actually generative AI tools exclusively for the specific task. Okay, so these are actually working based on the transformer technology. Okay, many of these and its variants, because you can have visual transformers, text-based transformers, etc. Okay, then you have a video generation is possible. Okay, so there are some platforms like Deep Brain, Synthesia, etc., etc. Okay, so again, I am not an expert in any of this. Okay, because say it takes a lot of time maybe to understand. At that time, you'll have the next technique will come. So you can concentrate on one of the areas and see maybe how you can actually contribute, because we cannot be able to touch upon each and every subdomains or sub problems nowadays. And you can say data augmentation, as I already mentioned. You can generate new data. Okay, so that is synthesis AI actually. Okay, you can build a new platform of creating using new automated techniques. So then generative AI is actually very important. Okay, and you might be already aware of that. You need a huge computing power. Okay, in the form of GPUs, graphical processing units, or TPUs by Google tensor processing units. Okay, these are actually some of the specialized hardware that can process the data parallelly. Okay, and one bad news is that actually they are highly costly. Okay, because depending upon you have a when you take you have A100 card, H100 card from GPUs, and I think the latest one is actually some GPU card is actually Blackwell or something like that. Okay, so they are actually from NVIDIA. Okay, so I think you might have recently read that Jack Ma or somebody, I think he's a CEO of NVIDIA. Okay, he's actually become maybe a rich person in the world. Okay, recently. So that's why the hardware accelerators are actually required, and you might heard of maybe some open source software where you can get these models like a Hugging Face. Okay, then you have a large data sets is required, because this type of deep learning you need either labeled or unlabeled data, but you need maybe large amount of data. That was earlier days, but now these models can actually even generate data from their own. Okay, and so that's the way this foundation models actually works. Okay, so that's the case. I think NLP is actually very important, because you know about Chat GPT, Gemini. Okay, that kind of tools where you are processing the natural language. Okay, uh, okay. In 5 minutes we will wind up. Okay, so NLP is very important. Okay, because here you are actually predicting maybe, so for example, machine translation, okay, or maybe from text to image conversion. For all this you need actually processing of NLP. But NLP was earlier considered to be a really challenging problem to be solved by computer science. Okay, because the ambiguity in the words, variation, okay, all these are actually, and how to represent the NLP was, a sentence, okay, maybe in a language was really challenging, because only if you represent in a, mathematically, these are actually possible to be processed. Okay, so then, so for example, one ambiguity example is actually, I can see a man with a telescope. Okay, so it can actually have two meanings at least. Okay, so I gave a present to the children. The chicken is ready to eat. Okay, so again, the chicken is ready to eat. Okay, so again you can have a ambiguity. Okay, so that's a way complex is actually NLP. Okay, and maybe the languages. Okay, thousands of languages. All these are actually challenging. Okay, and okay, again, how expressivity, because even a slight maybe modifications. Okay, maybe in the way we actually talk. Okay, express that particular sentence can also have a different meaning. So all these are actually challenges. Okay, and I think a representation is something like you might have heard of called embedding. Okay, so that means word embedding. Okay, how a particular word can be embedded into a vector space. Okay, so that similar, semantically similar words maybe are actually comes together. Okay, in a vector space. So that is a crucial challenge. But there was a tool called, models called word2vec. Okay, that actually changed the way how this language was represented in a vector space, and that has actually paved the way for maybe further developments in maybe the large language models, etc. Okay, so the large language model means, again, in generative AI, LLM is actually again a sub maybe application, okay, model. Okay, so this large language models is again actually working on some concept called encoder decoder. Okay, so again it's a transformer, okay, architecture. And there was a very famous maybe it's a path breaking paper called Attention is All You Need. Okay, this is a paper from Google Brain. Okay, so which has actually the key it's a state of the art, okay, paper in this particular field. Okay, I'm not going again. You'll have sessions separately on maybe how this all these are actually working. Okay, and so there are a lot of maybe language models developed starting from the word2vec. Okay, at the bottom you can see word2vec. Okay, and globe. Okay, there are a lot of things. Okay, then some of you might have heard of BERT architecture. That was also a path breaking. Okay, and finally you'll have this LL GPTs, that is generative pre-trained transformer GPT, which is actually the backbone of chat GPT. Okay. So all these are actually maybe very fast. You can see that in 2018, 5 years, it has got a tremendous scaling up. In terms of number of parameters, capabilities, etc. Okay, so that is a way. Again, so it is nothing but, for example, you have a sentence in one particular language. Okay, then there is an encoding. Okay, and the transformer architecture will take that encoding. Okay, that means how that is represented in a vector space, and then it can actually convert that embeddings into in an output language, something in different. So for example, this is in English. So this is actually it actually process the tokens. Okay, tokens means word by word. So as I already mentioned, these LLMs are actually using a probabilistic generative model actually. Okay, so for example, what is the probability that a particular a sequence of words are already seen? What is the probability for the next word? Okay, so that is a. So I'll go to another presentation. Okay, quickly we will wind up in 2 minutes. Okay, yes, this is a way how, for example, you know about Mary had a little lamb, something. So Mary had a, suppose you already gave to large language model, then assume that you have a vocabulary of words, then it will predict what is the probability that a context window of Mary had a given, and what is the probability for each word, in the vocabulary. Accordingly, the probability will be assigned. So there are a lot of math and a lot of other architecture that is going inside it. So, but ultimately, the input-output mapping is something like this one. Okay, then it has got the 0.4. Then the next word predicted token will be little. And now again, Mary had a little will be your context window, and accordingly it will predict the next probability like that. Okay, so and very interestingly is, suppose you have given, you ask your friend actually to give the same prompt to maybe ChatGPT or maybe Gemini or other similar tools, and see how varying is them. Okay, so here these models are actually not exactly accurate, because they are actually some probabilistic models. So there is always, they generate a probabilistic distribution for all these words, and they sample randomly from with respect to the context window, they will randomly sample that distribution, and there can be there's a randomness associated with that. Okay, so that will give maybe for example similar words. Or sometimes it can be wrong also. Okay, so that's why because if it is a stationary model, it cannot actually learn by its own. So it should be a random model. That's why it is not going to be 100% accurate at all the time. So it's actually learning by learning. So that means for example, if you are having for example a neural architecture here, assume that the pixels, then for an object identification, first it will look at the edges, then it will look at the parts of the objects, and finally it will identify a face. That's the way these systems are actually working. Okay, so that is another one. So this is the one I was mentioning about the word embeddings, vector space representations of words. Okay, so one very interesting thing is that once you represent these as vectors, then you can actually apply some linear algebra relationships. And that can actually give you exact prediction. Something like this. For example, in that paper, it is given that son minus father plus mother, is equal to say daughter. Okay, so you can have such results extracted from these kind of embeddings. So that means they are actually meaningful representations, and you will get maybe very accurate results or near accurate results in most of the times. So that is the case. And I think this is a RNN network I'm skipping. Okay, I think this is an example, maybe just example the capability of another type of learning called in-context learning, which is actually a feature of GPT-4. So you can see that this is a pattern, they have given 23 plus 45 is equal to 77, 12 plus 21 is equal to 24, 30 plus 21, what is the question? So if you ask to maybe ChatGPT, it will correctly predict it. Okay, so but it is a very complex pattern. usually how this works is the second number is actually reversed. So it means 23 plus 54 is 77. 12 plus 12 is 24, and 30 plus 12 is 42. It will be giving 42. Okay, so that's the way the intelligence is actually has improved. So that's again another thing. I'm skipping. Okay, I mean, these are some of the, I mean, I think prompting, I think most of you at least, okay, because nowadays you don't need to write any code or anything. You just prompt, and this LLMs or Gen AI systems will give you, I mean, results. Okay, but the skill set now people are looking is actually how good prompter you are actually, okay, how well you can maybe restructure your prompt so that you can get the best results out of maybe that Gen AI systems. Okay, and so that is a prompting. Okay, I think this we will skip it. Okay. Okay, this is also again all the such things, and this is a very maybe edge AI. There is another area called I think Shubhomar sir was mentioning about the architecture, hardware architecture. So I think you know about edge computing. Okay, now maybe it's something like IoT systems and other things where you need actually they are actually low resource computing devices, where if you want to run these models of millions and billions parameters, then there should be some optimizations or device perspective and algorithm perspectives. All these are actually discussed in edge AI. Okay, it's a very promising field. Okay, because this is anyway going to revolutionize maybe some of the research directions, integration of LLMs in edge AI for autonomous agents. Okay, then interoperability, something like this. For example, we talk about Windows and Ubuntu systems. So how such compatibility is possible with respect to edge devices, etc. I think you will have sessions on that one. And the last one is actually the foundation models, where you pre-train, okay, with large amounts of labeled and unlabeled data, and you come with a model, and now you can use that model with some fine tuning or in context learning or some other type of maybe techniques which can be used for multiple downstream task. Okay, so that is the way now this is changing. Okay, foundation models, but to set up a foundation model by us is actually really challenging, because you need a huge amount of data processing power like a GPU, I mean even hundreds of servers, etc. But what we can actually use is actually we can fine tune or maybe or apply some techniques. Okay, and there are some open source models also, because if you want to use ChatGPT, you have to pay for its API if you want to fine tune it, so it's costly. Okay, but you have some older versions will be available. Okay, so this is actually about the maybe the foundation models. So that's the latest one. I think with this I will stop the presentation here, and okay, maybe we'll have a few questions. Okay. Okay, I'm not actually an expert on this one, so I will try to answer maybe based on what the knowledge, okay, that I have. Okay, thank you. So right now only I have just looked into number of participants. It is 222. It's great. I think that's I mean, we should congratulate the organizers okay, for bringing that many number of maybe participants. Okay, so thank you. Okay, it was a nice experience.
Thank you, sir. Yeah, is there any question from the side of participant? Already, I can see that there is a hand raised by Soumya CJ. Madam, do you have any question?
So can
Otherwise-
you elaborate graph neural networks?
Pardon?
Can you elaborate on graph neural networks and its application? Graph
Actually, graph neural network, usually what is done is, for example, I think you know about the basic graphs. So here, generally what we need is actually there should be a embedding of your input data into graph nodes. Okay, and there are some specific algorithms that you can actually apply on maybe this graph which has got each of the, so for example, when I say embeddings, what are the information that you are actually storing on individual nodes, and those information should be mapped into maybe a suitable maybe vector dimension. Okay, and then that will be the node representations, and there you will be applying some specialized algorithms. Okay, and that will give you maybe, say for example, the relations, etc. Okay, with respect to maybe the associations or maybe a relationship with the particular maybe say node embeddings. So that way you can actually again look into the results, and then you can get some inference. But I have actually we have used maybe graph neural networks called a graph sage. Okay, that's a special algorithms. We have actually used that for maybe predicting maybe say diseases. Okay, maybe if you want to know more on that part, okay, I can share maybe separately. Okay.
Okay, sir. Thank you.
Okay, thank you.
Yeah, thank you, sir. It was a very useful session. In fact, Dr. Gopakumar started with the definition of AI and then introduced the basic terminology such as supervised learning, unsupervised learning, reinforcement learning, semi-supervised learning, all these things. And he has touched different AI technologies that are in place currently. And in the coming days, we will see in more detail about these technologies. And I thank once again Dr. Gopakumar for providing such an insightful session as the opening session of this SBT. Thank you, sir.
Thank you, Shubhumar.
Yeah.
Once again for a chance.
Yeah, thank you. So,
Thank you, sir.
Thank you, sir.